All right. There we go. Are we seeing the slides okay?
Yes, I can see him.
Okay, great. Well, my name is Matt Voss with NearSpace Launch. I'm the Chief Operating Officer here, and I appreciate FreeFlyer to let us share about our black box. And it's been a pleasure working with AI Solutions on this process. So I was asked to kind of just share about how our journey to working with AI solutions and using FreeFlyer and just the process of the black box and where that came from and who NSL is. So I'll start sharing about that today. Overall, NSL is a manufacturer of small satellites from CubeSat market. I'm not sure how many of you are familiar with that, from 12 U's down to 1 U's. We also flew thin-sat constellations along with Istar radios from the Istar S3 to the S4, along with the black box, which we'll be sharing about today. We also have a chief scientist, chief engineer, about 7 years of experience. We're a small team. We're about 6 years old company. And then we've worked with all the different major government entities there, along with a lot of the industry. And we partner strongly with Iridium and Globalstar constellations, and that's the heart of our connection to our Istar radios, partnering and representing them in orbit. To kind of give you a little more of our story. So we're about 6 years old, but we have over 700 systems in orbit in the past 5 years. And we also have about 180 Istar radios connected through the Globalstar Iridium systems, along with, we just passed our 100th satellite in orbit as well. So we were excited. It's been a busy couple of years for our team here. And then from that also was developed the black box back in 2018 that we were launched in partnership as well. So a lot of different projects going on here and just some of our highlights of that, and connecting with a lot of different great groups to make that happen and different customers. Just to give you an idea of the Istar, so the one that we flew 180 of, is it connects to basically pre-existing constellations. The standard classic SATCOM pathway for satellites is, you have your satellite and it has a good connection to a ground station, so sat to ground station model. So our model is working with the pre-existing other satellites that are in orbit, such as the Iridium and Globalstar, and we point our antennas up towards them. And so as while we're going in orbit, we can connect to them even over the oceanic or the polar regions, and then downlink to a ground station. So it could be a bent pipe or it could be satellite to satellite, depending on the constellation we work with. But that has been a lot of advantages of global reach, and we'll talk a little bit about that Istar, because that will be the heart of the black box, which leads to then our need for flight analysis. And so Iridium and Globalstar, they're usually used as search and rescue or asset tracking terrestrially. So we adapted these technologies and these constellations to be also used in space. And so that's where NSL started out before it started manufacturing its own small sats and space weather instruments, was our connecting to these previous satellite constellations. Just to give you a big picture here, one last snapshot is basically you have your constellations. We have our Istar CubeSat constellations in orbit that are connecting to these different satellites. We also have high altitude balloons that are using these as well. They're going up to the top 1% of the atmosphere and about 35 kilometers. We also had some terrestrial uses that we were asked to look into from the DoD as well. So we've done a lot of different variety of connecting to these networks and then following through on that. Just to kind of talk about the Istar, it's a very small, this is the system right here, the Istar S3. We are moving to the S4 now, which is a half duplex versus simplex. It has a 24/7 data collection. It turns on in seconds. It's connecting globally, so we've gotten a characterization of that, as well as working with the value added network. And yeah, it has a quick turnaround. So it's a very simple system that is used terrestrially, but we were able to enhance that Istar and be able to get it ready for the environment in space while also going 1,700 miles per hour and a lot of other factors to go in there. This is some flight data that we published on the Gears 3 mission with AFRL and kind of showing some of the particle detector, and through our lineage on a short mission of a few days, we were able to also characterize it in the polar regions, collecting data from all parts globally. One of the other things that we've learned through our different flights with the Istar is that it can handle high tumble rates. So even if it's in a 12 RPM and spinning, it can still connect to your satellite. So usually you need a stable platform, such as a 1/4 RPM before you can connect to a ground station on Earth. And so, but even at 12 RPM, we've been able to see and higher in those spin ratios, we can still connect to Globalstar Iridium constellations. And so we're excited about that. That's been a really good mission assurance thing for different groups and helping them move forward. We've got a full part through the NSL console, and that is the part where FreeFlyer was really helpful to enhance our console to add some great mission capabilities, because we were taking the information from the constellations, from our satellite to constellations, down to our database through our console, and yet we need a lot more mission management using FreeFlyer capabilities. So what's the purpose of this black box? Where is this coming from? So we had all these Istar technology a couple of years ago, and people were starting to use that, and it was helpful for operators as they needed to get critical data down. It was kind of a low data link, but then we were able to go forward, and this is just the small sat market. It's definitely increasing. It's projected to go even further up in this trajectory for a long time, for the next 5-10 years. It's just a rapid growth, and so space traffic is becoming a thing that has been an important topic for us. And so just with all the increase of 200% in the last 5 years, 700 units, like there's a lot of projected growth in the space tracking, and then also making sure there's no space debris kind of thing. So our basic concept with the black box is this is just the idea of trajectory. We published on this at SmallSat and also IAS, and this is just kind of the idea that we have a lot of satellites in orbit. Our conjunction windows are very wide, and then with GPS data, we can help shrink those conjunction windows so that we can have a lot better understanding of the space traffic, but also IDing these satellites better as well. So we had our first flight as a customer, in this case coming from spaceflight. They were wanting help with just using our Istar, but then attaching GPS capabilities for that data that was being downlinked. So we've been interfacing with different GPSs and working with our Istar to get that data through. And we were getting good GPS data through, but then we want to do better on providing flight data analysis, and that's when we started looking to AI and also solutions and Taylor University, which I'll share about in a second. But we progressed further after with spaceflight and worked with and did a very small business research with the 18th Squadron, who does a lot of the tracking of space objects in orbit, along with AFRL-RV. They have who focus more on mission assurance and quality of those. So this was a tech award that was, so we've made a form factor from the previous one, which we did with spaceflight, for one of these black box standards, we call these, and it has a form factor that you can put the GPS and batteries and your antenna on there. And then we went ahead and also had a small sat patch, which was a smaller form factor, only about this size here. And the nice thing about this is it fits right on the side of a CubeSat. So this is a 3U CubeSat that one has. You can actually just take it to the side of it and put it on almost like a barnacle. Pretty simple interfacing with the satellite. It can stand alone as its own satellite. This is a Pico satellite, basically. It has its own solar cells, its own EPS, and be able to track those different things. So we're really trying to come for a solution on that side for space tracking and critical data. And we were able to get these into orbit pretty rapidly. We had troop missions, train rapid on orbits through TagSat that were launching every 90 days to even 3 months. So we were doing characterizations, trying to find the best GPSs to get those through while using the Istar tracking those capabilities. And so we made different types of black boxes that would work for those, from the Istar to the tag with just the GPS. So knowing that a lot of different operators needed different options. And so these are just some of the trade-offs that people could look at and review for their mission and see what they need. So we had a lot of a hardware solution kind of working through it, also proving out the technology that it can work well in orbit. And then we needed partners to really help us in the data review and taking that GPS data and then bringing in confirm TLEs and also ephemeris side of things. So we partnered with Dr. Kiers at Taylor University and AI Solutions and their team were very helpful in helping NearSpace launch validate a lot of this data with our team and bring that through. So basically, some of these slides were shared from Taylor University. and I'll continue to share through some of the flight data of some of the flights we had there. So approximately we had our first flight in TagSat-1 in January of 2021, and then it was reanalysis in TagSat-1 using FreeFlyer later that year. And then we had a TagSat-2 mission, another SpaceX transport mission using FreeFlyer, and then we were able to automate the orbit determination. And so it was being done by hand, and we wanted to move it through FreeFlyer, but then also through FreeFlyer's API. And this is kind of a schematic of that. We have the NSL web console. The user chooses the radio within our console that they want to use. They submit it. The request goes through FreeFlyer's API, and then it hits that orbit determination. And then from there back to our console. And even if the customer chooses to, then we can also pass that on to the 18th Squadron as part of our SBIR. We were able to have that integrated into it. So orbit determination of TagSat-1 was launched in January 2021. Prior to using FreeFlyer for orbit determination, we adopted a simpler gravitational model and performed coordinate transference manually. The GPS data was sparse for this satellite prototype as we were collecting a lot of different data. And it received very reliable data for a couple of blocks, approximately 16 days after the launch. So this was before we were using the FreeFlyer data. The blue was forward propagating from the insertion data, and then the green was backwards coming from the GPS point there, lock at 16 days. So it was a very strong, valid one. There's approximately about 5 minutes out of phase at the meeting point through the calculation of Dr. Kears there, so rather lined up. Then they were able to reanalyze it later with TagSat-1. The red dots represent the insertion data from the launch and able to propagate it to 16 days. It was really neat to see how this really lines up really well. The black dots then was using FreeFlyer's orbit propagation backwards and seeing how they line up. And then the green line was also the one provided by Taylor University using their simple differential equations and simplified gravity model. So we had a good significant alignment for that whole process. We also had TagSat-2 results. The data was somewhat sparse. It was our second mission. This time, though, we were able to use FreeFlyer from the beginning as well for the orbit determination, insertion of the residuals using the batch least squares, just because of the just several points that we used to give the average across there. And AI Solutions was great to recommend that methodology, and we were able to get from that then generate a usable ephemeris and a TLE for our clients. So that was great that they were able to start using the black box as part of the mission. And compared it to fit for the propagated insertion data and observations, and then we fit for the TLE was better than that for the ephemeris. The improvement of the fit was also part of the project that they performed, trimming of the fit time span, adjusting the different parts here, adding the insertion data for the prior state, trimming bad data based on constant energy, fitting by the estimation of the orbit elements, and really found FreeFlyer a big part of that, along with Dr. Kears, on the improvements of that fit. The automated part of this then was part with Dr. Stephen Brandel, another partner at Taylor University, to really help bring that interface into a generated the TLE and ephemeris in the console to go to the 18th Squadron. And so these are just some screenshots that I will share for you here. As it was mostly through the back office there, but the user selects a particular radio as well as the output type from the ephemeris and the TLE, and then the server fetches the GPS data from the database, launches Python code to communicate with the FreeFlyer API. They perform the data is returned to the server in the requested format. So they worked with different groups there, from GOES to TagSat, some of our other missions to test out the data. You could choose this one. This is one snapshot of a screenshot for a TLE. You would take it from the mission here, generate it there. The results can be copied into a clipboard, or you can look at the data right below, such as the summary and the results. And then we also have the TLE right at the bottom. Then we also have the ephemeris output as well, capable. So obviously a little more detail, and same kind of process that you can set through these options. So the review of the work with FreeFlyer, FreeFlyer validated the TagSat GPS data and the NSL calculations for an accurate TLE and ephemeris. We were able to automate the process and shrink the conjunction windows as well. We have some publications of this through the ID GPS tracking that was done through SmallSat and also at IAC different missions. So that was thankful for our time with AI Solutions and FreeFlyer from both the NSL and Taylor University. Our next steps is that we have a June 2022 Falcon 9 Transporter 5 launch to expand the capabilities and mapping characteristics. It's going to be jumping from the S3, which is a simplex, which is the part of that is, and the next point is that we're moving to an Istar S4 half duplex, which gives commanding capability. So we'll have some neat projects to be able to test with that. We're going to also test further FreeFlyer's capabilities and integrating it with our missions on this and validation of black box. And then we were just awarded a joint Space Force contract with AI Solutions and Taylor University to further expand some services. We'll be looking at some also propulsion ideas and looking at how this can work across a lot of different missions here for NSL. So thank you for letting us share today with NearSpace, also representing Jeff Daly, Matt Voss, and Dr. Matt Voss, and also for Taylor University, Dr. King Kears and Stefan Brandel and Andrew Glaze. And Dr. Kears is actually here with us right now as well, and he'll be glad to answer or discuss questions with us if you guys have any. But thank you for letting us share today. Appreciate that.
Cool. Thanks so much, Matt. We do have a couple questions from the audience. The first one, you kind of touched on the next iteration of your Istar, but what type of data can be sent currently over the Istar radio?
So it's low data rate that we can bring that through here. And actually we have Matt Voss here with us right now. He's one of our engineers. So he can share about the Istar S4 and what kind of data can be brought through that as well. So Matt, would you like to answer that question?
I didn't hear the question.
No, just with the Istar S4, what kind of data can be brought through that?
Yeah, so you guys can't see me, but I'm here in the room. The Istar S4 is mostly a low bandwidth data solution. So most of it is sending down health and safety and telemetry of the satellite itself, maybe some mission critical baseline sensor data and payload data. Something that can really complement a higher data rate solution. The main benefit being that it's able to get that 24/7 global coverage. So there's no downtimes or periods waiting for a ground station pass to be able to have a live connection to the satellite. And the other benefit is the live uplink capability as well. So the ability to issue commands without having to wait for a ground station in real time. So if we notice something's going wrong with the satellite, we're starting to go into a power negative mode or something on board is starting to fail, we can immediately issue a recovery command to put it into a safer mode and recover the satellite.
Mm-hmm. Oh, does that answer your question, Mark, or were you looking for?
I think it does.
Great.
So next question is, so who has access to the console? Do you have customers that sign up for a service, access the console for their specific mission? Do you deal with the console and you provide the data for them? How does that work out?
Yeah, fair question. So basically, yeah, that's included with every Istar or black box, which is in there. So it comes, so that's anytime they get an Istar, basically they would get one ordered and they would get access directly included with that to the console at the moment here.
Okay. The next question was about the TagSat-2 mission. Do you know why the tracking data was so sparse for those missions?
There's a couple different reasons that we were looking through. It was multi-mission. There was different data that was being brought through it. We were looking at, there was some RPM as far as it was rotating. So it was hard for locks. So there's a couple different parts there to the mission. It was also us figuring out how much data that GPS we were wanting to push through as well. I think we're hoping in our June launch that we'll get even further locks in the way that we're setting it up in the mission that's coming up.
Okay. Next one is from the FreeFlyer team. Do you have any enhancement requests for FreeFlyer that would help facilitate these analyses and integrations into your operations?
Well, Dr. Kear's working with most of that, and I think it's mostly positive feedback. And actually, I'd love to bring him on board here to answer that question since he's one of your partners in that. So,
sure. Hello. I honestly don't have anything right off the top of my head. I have given this a little bit of thought, actually. what I can say is the tech support team was fantastic. We were really last summer when we started using this, we were just starting to learn how to use the software and the scripting language, and the tech support was unbelievably helpful. I don't have anything off the top of my head in terms of suggested improvements, but if we think of things as we continue to use it, we'll certainly pass those things along.
Great. Yeah, we're glad to hear that tech support was able to help you accomplish your mission goals. I think we have one last question. Were there any challenges with connecting the FreeFlyer API to the NSL console?
I mean, it was a little bit of a technical challenge, but we had a computer science team that was kind of more involved with setting up the website. Basically, they set it up so that when someone initiated a request, it just ran some Python code that we had written, and the Python code pretty seamlessly went and called the API and got back the data and stuff. And again, the FreeFlyer tech support team was very helpful in getting the Python part running, and then it was very straightforward, I think, for the server to just call that when there was a request. So it was pretty straightforward, really.
Great. Okay. Well, yeah. Thanks, Matt. Thanks, NearSpace launch team. We're happy that you could talk about your experiences with the FreeFlyer. You have a pretty cool and unique capability with your Istar radio and your black box. Once again, we really appreciate you being able to talk at the FreeFlyer Expo.
Yeah, well, thanks for having us, and yeah, thanks for letting our team share. This is definitely a group effort for this mission, so appreciate you all being part of that with us.